What is up, guys? In this video we're going to be doing some trigonometry. So I'm going to start from the very basics. You have a right angled triangle with red as the hypotenuse, blue as the perpendicular, and green as the base. Now we'll find we'll use this triangle to assign some value to the first three identities we have: sine, cos, and tan. From that we'll get the other six. Oh, not the other six, the other three. There are total six: sine, cos, tan, cosec, sec, and cot. So sine is perpendicular upon hypotenuse, cos is base upon hypotenuse, and tan is sine theta upon cos theta. I don't normally, one thing I might do wrong is I might not say theta after tan. I'll just say tan because I feel like it. So that's something that I may do wrong, so apologies in advance. So cosec theta is the inverse of sine theta, sec theta is the inverse of cos theta, and cot theta is the inverse of tan theta. So if you know the first three, you get all of the others. And one thing I realized that I may have failed to include is the angle values for trigo. Now that I think about it, like, I'm in editing right now. That was really stupid of me, but then why do I do such stupid things? Let's just go on. And here's the little thing that can help you remember it easily. You can use whatever the hell you want. It's normally PBP by HHB, and then it's sine, cos, tan, and then on the bottom it's cosec, sec, and cot. So you got it there. So the first three identities that anyone should know stem from this one identity that everyone has to know, which is sine square theta plus cos square theta equals 1. Because from that you can get everything else. And I think, and I did include the derivation of sine square theta plus cos square theta equals 1, not in the lame way, in a good way, the better way. So here we have to you can divide it with sine square theta. It'll still be the same, but then you just get it for other identities, like other trigonometric functions. You see, from sine and cos you got cot and cosec. Now if you divide it by cos square theta, the whole thing on both sides, you'll get tan square theta plus 1 equals sec square theta. That's pretty cool, right? So now I'm gonna draw a little graph and I'm gonna explain to you. So red is gonna be the distance on the x-axis, which I'm gonna take as small x, and blue, it's gonna be perpendicular distance, which is gonna be small y, and I'll just draw it here too. And green is gonna be the hypotenuse connecting them. You can take the hypotenuse as whatever the hell you want, it doesn't really make a difference, but I took it as 1 because that's literally the easiest way and the most simplest. So sine theta, as we know, is perpendicular upon hypotenuse, so y by 1 is just y, and x by 1 is just x. So sine theta is equals to y and cos theta equals to x. Now that you have these, you'll just use Pythagoras' theorem, and you'll get your little guy sine square theta plus cos square theta equals 1. Now we're gonna go for sines and the quadrants. You know, which functions, trigonometric functions are or ratios, actually trigonometric ratios are positive in which quadrants, and so first we're gonna go into the first we're gonna check out the okay, we're gonna take the first quadrant first. Yeah, oh my god. So purple is gonna be the hypotenuse, which is positive, always positive, because even if x or y are negative, because when you square them the negative thing disappears, so it's always positive in all the quadrants. So in the first quadrant, x your base is positive and your perpendicular is positive, so every single trigonometric ratio is positive here. In the second quadrant, only sine and cosec are positive, because here the base is negative but the perpendicular distance is still positive, and the hypotenuse, as you know, is always positive. So hypotenuse upon no, it's base perpendicular upon hypotenuse, those are positive upon positive, which will just lead to a positive quantity overall. So yeah, and in the third quadrant it's only tan and cot, and in the fourth quadrant it's only cosec and sec. Third quadrant, because both the perpendicular distance and the uh, base are negative, so negative by negative it cancels out, so you'll be left with positive. And here the hypotenuse is positive, but and the base distance is positive, so your cos will be positive. Now I wrote angle measurements here, but it completely slipped my mind to start from 0, 30, 45, so you won't get the how to find sine 225, cos 15. That's completely my bad, but you'll be able to, once I cover the class 11 identities, you'll be able to find it out anyways easily, because to know class 11 you must know class 10, and if you know class 10, you're pretty chill. You're chill. You don't have to worry. Now here I'm discussing, and now here I've written how if you're moving in the anti-clockwise direction, then your angle is positive, but if you're moving in the clockwise direction, your angle is negative. That's primarily how the quadrants work, so that's also how the angles work. Now here, what radians are, they're like the unit measurement of angles. So I'm going to take a graph, and I'm going to take so you see x dash, it's a straight line, so the total angle is going to be 180 degrees, and when we draw y it's going to be 90 and 90, because y is perpendicular to x dash. So I'm going to take that as 1. Now if I curl 1 to make it in the form of a part of a circle, like let's say there's a circle with radius 1, and a part of the circumference I take as 1 centimeter of the circumference, that's going to be 1, and then we're going to add another one, it's going to be 2, that's 2 already, and the last one's going to be 3. So then you already have 3, but then there's going to be a small gap between the thing that you're trying to draw and the x dash axis, and this small gap is 0.14159 dot like onwards. It's basically it's never ending, it's continuous and non-repeating. So when you add it, the total semicircles thing is 3 plus 0.14159 dot dot dot, which is just pi. So 180 degrees is just pi radians. So now you'll also notice that degrees has the circle and radians has the c, so don't mess that up, otherwise it'll confuse you and you'll mess up. So from 180 equals pi, you can find out almost every other one, like 45, 30, 60, 360. 360 is important. 360 and 180 and 90. 45 not really, 60 not really, but then it's good to know. If you know 180, you know it all. I went back to put an underline. I don't know why I did that, but felt like it. Okay, so now let's just let L be small part of the circumference of a circle with radius r. So if O is the center, then the angle subtended by this thing is, and this theta. If we want the angle measurement in radians, it's going to be L by r, which is length of the arc by the radius. But if you wanted to find theta in degrees, you could use this little formula. It's basically L is equals to 2 pi r by 360, and now just move the stuff over. Use L equals to 2 pi r into theta by 360. Just move over the stuff and you got it. That table is pretty important. And then there's also one more thing about minutes and seconds. So 1 degree equals to 60 minutes, and 1 minute equals to 60 seconds. So sometimes questions may appear with like you have to convert like 47 degrees and 30 minutes into radians. So yeah, it's not that hard. It's fine. Oh, okay. So now I'm gonna go for the values of theta. If we draw a circle with O as the origin, O as the origin and the center of the circle, you see how there's these lines, the x-axis, y-axis, x-axis, and the y-axis. So we're gonna take red again as the distance on the x-axis, y blue, and hypotenuse, which I've taken as the radius because it's the distance from the center of the circle to a point in the circle, so that's the radius, as r. Now using what we did before, you all just saw it, so you're gonna find sine theta, which is gonna be y by r. So then y is equals to r sine theta. And why am I not writing it? Okay, yeah, there we go. Y is equals to r sine theta, and x is equals to r cos theta. This could be this is important actually in vectors, but then we're doing Trigo right now, so forget about physics and just think about this. Now here I was planning on doing something else, but then I realized that my figure wasn't exactly, I couldn't do 2 in 1 with my figure here, so I just left it as is. For any value, oh yeah, now I'm gonna go into when sine theta is 0, and we're gonna go for what theta has to be and the conditions for that. So let's go on. So the first case we have is sine theta equals to 0, but in this case theta has to be equals to n pi, and n has to belong to an integer. Anytime now. I'm editing, man. I should probably speed this up. 1 sec. Now we're sped up. Nice. So that's the first condition for sine theta equals to 0. Now we're going to go for cos theta equals to 0. Now this one's a bit more, unique, because the other one was just n pi, but now cos theta is equal to 0 only when theta equals to 2n plus 1 into pi by 2. And you have to get this into a format where n's an integer, and only then can it be 0. So good luck, yo. Now we go into allied angles. So let me just draw like graph that's actually appropriate. So I shouldn't write 2 pi, pi, and 3 pi by 2 right now. So I'll explain it first, and then I'll draw it. So we're gonna go for quadrant rotations first. So say you have a certain distance, I'm gonna take it as red distance, and you have to move it to the y-axis, or you're just moving it. When it's on the y-axis, your line is gonna have moved 90 degrees. So you can convert that to radians, so that y-axis is also pi by 2 and 90 degrees. So then you move it another 90 degrees, that's 180 degrees. So then that's pi. Now similarly, y dash is 3 pi by 2 because it's 270 degrees. And then x is just 0 because you start there, or it's 360. 2 pi. Let's make it a bit more simpler, yeah? First one is pi by 2, then we go forward, that's pi, then we go again, that's 3 pi by 2, then we go again, that's 2 pi. And then you can keep going on and on, but then this is the simplest form, you don't need more than that. Yeah. So now we're gonna learn. So this is an important rule. Sine minus of theta is equals to minus sine theta. But then that's not the case for cos theta. Cos minus of theta equals to cos theta because cos is an even function. So there's going to be no change on the x-axis, but then y-axis is going to have changes in the trigonometric ratio. So by x-axis, I don't mean there's going to be no change at all. There's just going to be no change. Like sine will stay sine, cos will stay cos, tan will stay tan. But for the y-axis, it's going to change. Sine goes to cos, cos goes to sine, tan goes to cot, cot goes to tan, and cosec goes to sec, and vice versa. So now the first rule, which is going to be in the y-axis, sine pi by 2 minus theta is equals to plus cos theta. And why is this? Because sine pi by 2 equals to 90 degrees, and when you subtract an angle theta from 90 degrees, it's going to be in the first quadrant, and in the first quadrant every single trigonometric ratio is positive, so it's going to be plus cos theta. But sine theta doesn't depend on whether cos theta is positive in the quadrant or not, because even if cos theta is positive, it depends on sine. It depends on sine's value. So sine's the big dog here. You add theta. Here sine is positive, but cos is negative. But just because sine is positive, cos is going to take it. Second quadrant and first quadrant, sine is positive. So yeah, you got that, bro. Now we're going to take 180 degrees. So when you subtract theta from 180 degrees, it's going to lie in the second quadrant. So that's going to be a positive sine theta because we're dealing with the x-axis now, and there's no change in the trigonometric identity when we're dealing with the x-axis, as I mentioned previously. So plus theta is going to equal minus sine theta because now we're going to be venturing into the third quadrant. Give the minus sign, man. Oh yeah, I have to explain it, sorry. So as we go into the third quadrant, only tan and cot are positive here, so yeah, it becomes minus sine theta. Now sine 3 pi by 2, it's similar to the y-axis, but it's just negative, so it's going to be minus cos theta, and sine 3 pi by 2 plus theta. This is going to be in the fourth quadrant where cos and sec are positive, but because sine is negative in the fourth quadrant, cos inherits the negative sign. Yes, bro, we see you writing. Write faster, man. Yeah, because sine. Yeah, yeah. I got that. Let's go, big dog. Right. Come on, man. Oh, question. Okay. So, you have to turn sine 5 pi by 3 into degrees. And I spelled that wrong. One sec. Yeah, got it. So here we have sine 6 pi by 3 minus pi by 3 because we wanted to get it in a 2 pi form or something without no decimal. I don't like it when there's, fractions. So 2 pi minus pi by 3, that means it's going to be in the fourth quadrant, which means it's going to be negative, not positive. Ignore what I'm writing because I was in a rush. So it's going to be minus sine 60, so it's going to be minus root 3 by 2. That's going to be the answer. So, you know, I know it's ironic that the guy making the video makes a mistake, but then I was also in quite a rush because I didn't have the ability to edit while I was, and my notes crashed. So I did lose pretty much half of my work so far, but we're gonna start fresh with, can't believe that happened because like the notes are actually going so well. Oh, double star, yellow font, trigonometric identities time, baby. Now these are weird, dude. This is 11th trigonometric identity. So first thing, quite simple. Cos x plus cos y equals cos x cos y minus sin x sin y. Now you notice how these are in pairs. Cos and sin are in pairs, but just different x and y. So the trigonometric function is same. I'm assuming because there's something to do with cos being an even function. And here we see how in x plus y there's a negative sign, but in x minus y there's a positive sign, so keep that in mind. Sin x plus y does not have the same property as cos, where it has the same trigonometric function per thing, so it's sin x cos y plus cos x sin y. And also, just one more thing, don't confuse sin x and sin bracketed x because sometimes I'll neglect the brackets. Just don't accidentally cut them off the identity, the trigonometric ratio. Yeah, I should probably calm down. I'm blabbering. Make sure, look out for the minus and plus signs. Now it's tan x plus tan y by 1 minus tan x into tan y. Then it's tan x minus tan y. The top sign will become negative and the bottom sign will become positive. Yeah, I'm writing that down right now. This might seem kind of weird because, as you are hearing it, it seems like I'm talking to myself, but I recorded this video about, what, 2 hours ago as I'm editing right now. So I'll go back on topic. Now, cot x plus y, you're just going to flip around tan x plus y, but then you're just going to turn the cot, you're going to turn the, tans to cots, and then you're going to change the signs. See? Tan is to cot, just flip it over. Cot x plus cot y equals cot x cot y minus 1 by cot y plus cot x. Now cot x minus y equals cot x cot y plus 1 by cot y minus cot x. Now make sure you don't mess up cot x and cot y's ordering because cot y comes first, cot x comes later. Now for the fun ones, let's run it. Run it, boy. Sine 2x equals 2 sine x cos x. You can easily derive this one, but then I just like writing it down because efficiency, Sin x plus x. You use the first one, sin x plus y, so it's sin x cos x plus sin x cos x. So it's 2 sin x cos x. That's how we got it. Now it's time for tan 2x. Cos is coming right after this. 2 tan x by 1 minus tan square x, because you have to just go off of those ones. But I'm just mentioning 2x and 3x's because you're not always going to have time to, find it out in the moment. So it's good to write it down. And because of it being an even function, cos x, and sin x, they group together, so that you get cos square minus sin square, cos 2x. Nice. Yeah. You can get cos and tan and the other stuff just by doing the same thing that we did before. So now I'm gonna get to the juicy ones. Cos x plus cos y, not cos x, but yeah, cos x plus cos y equals to 2 cos x plus y by 2 into cos x minus y by 2. Okay. And I'm gonna quickly let it save. I'm adding some colors because it might get boring because I'm only using white. Let's pick a random color. Yeah, I like the lime one. It's nice and vibrant, eye-catching. So now cos x minus cos y equals to minus 2 sin x plus y by 2 into sin x minus y by 2. Or I should probably stop speaking so you can, take it down however you like. I think I'm finally done now. It is now 10 p.m. at night, or exactly 17 minutes and 2 hours after when I was drawing this random guy. My summer break started. So, what up Awaz, what up Ishmit, what up Avinab? Drop a comment or something if you made it this far. You know what? I should probably solve a problem. Let's solve a problem. Let's go, boys. I was looking for a decently tough problem in my book, so found one. It wasn't exactly hard, but then it's still good to see how it's done. If alpha and beta are acute angles such that tan alpha equals m by m plus 1 and tan beta equals 1 by 2m plus 1, prove that alpha plus beta equals, let's use red, alpha plus beta equals pi by 4. We already have tan alpha and tan beta. So what we're going to do is we're going to use tan alpha plus beta formula. So we can get a singular value for tan, and we can use the values, we can use the things that we have, the trigonometric ratios. So tan alpha plus beta equals to m by, right fast man, come on, m by m plus 1 plus 2m plus 1 by 1 minus m by m plus 1 into 2m minus 1. I'll just shut up and I'll let myself do the talking. No, I'll let my work do the talking because, I forgot to write, tan alpha plus beta equals to, but you'll get it. You get it. Come on. So I apologize if you may notice any like, small errors or big errors, because this is my first time. Not really first time. I've done two more, but then those are very short. This is my first long form video on any topic or chapter. So if I do get time, I'll make more. And when I do make more, if I get more time, if I make more, I'll definitely work on the quality. So, oh yeah, I went back to show that we should never forget the objective and don't just keep going forward. If you get this simplified form, just get it as 1. So then tan alpha plus beta equals to 1. Now, I didn't mention the values, but then tan 45 degrees equals to 1. So I just wrote down a couple of values here, and my Apple Pencil's almost dead. So 1 by root 3, 1, and root 3. So we need 1. So tan alpha plus beta equals to tan 45 degrees. So then we're going to convert that to radians now because that's what they asked for. And 180 by 4 is equals to pi by 4. So then tan alpha plus beta equals to tan pi by 4. So then you can't exactly cut tan, but you can remove it. Just don't show the cutting, because then that'll be wrong. So then you get your answer. Alpha plus beta is equals to pi by 4. Hence proven, or thus proven, whatever I wrote. Yeah, thus verified. Oh, wow. Big boy, huh? My Apple Pencil is low. Got to go, bro. Okay.